All right, so for number 15 here, we got this function. We want to know which is true. Basically, we're looking at continuity and differentiability. So if the function is going to be continuous at 5, we need to plug in 5 to both the left and the right of this and see if it's the same. So negative 5 squared plus 3. And what does that come out to be? That's negative 25 plus 3, so that'd be negative 22. And then we've got negative 10 times 5 plus 28, which gives us negative 50 plus 28, which is negative 22. So yes, it is continuous. We can eliminate choices C and D. We could have eliminated choice C anyway without even doing any work because the function can't be differentiable at a point if it's not continuous at that point. So now it's just about whether it's differentiable there. So we'll take the derivatives, negative 2x and negative 10. And so if we evaluate each of those at 5, it is true. So it should be continuous and differentiable. Does that make sense to everybody? Sometimes they will give you, oh, perfect. My internet connection is unstable. Can you guys hear me or no?
We can still hear you.
Oh, good. Okay. Sometimes they might give you one of these where if you take the derivatives and plug it in, it works out, but it doesn't work out for the continuity. And so if it's not continuous at that point, it can't be differentiable at that point. So don't let them fool you by making you think that because the derivatives match up, that it must be differentiable, that it has to have both of them be true for it to be differentiable. All right, next one, number 20. All right. So we want to know, given this information about the integrals from 1 to 4 of f and g, which of the things can we not figure out? So first off, the integral from 4 to 1 of g, well, that's 2. We can figure that out. We just flip the limits of integration. The integral from 1 to 4 of 3 times f of x is 3 times 8. We can figure that out. Part C, if they're being multiplied together, that creates a new function that cannot be separated using an integral. So this is the one we can't figure out. This one we could. This one is just 24 plus 2. So C is the only one we can't figure out because they're being multiplied together. And you can only separate integrals using addition or subtraction. Any questions on that one? Everybody good with that? All right, next one is 83. So for this one, we want to know for what value of k is the function continuous. So for it to be continuous, we just need to plug in 3 from the left and 3 from the right and need to set them equal to each other. So that would be k cubed plus 3 equals 16 over k squared minus 3. And we need to figure out when is that true. So the only way to figure out when that is true, not the only way necessarily, but the easiest way to figure out when that is true is to graph both of those functions and see when they intersect. So one of them was what was it, x cubed plus 3, or was it minus 3? Plus 3. And the other is 16 over x squared minus 3. And so then we just need to look for where they intersect with each other. It looks like they intersect with each other here at 2.081. And so that's the k value that makes that true. Choice A. Any questions on that one? That makes sense to everybody? No problem. Other questions that anybody might have? Number 10. Okay. 1 second here. All right. So we're given a graph of f, and we want to figure out some stuff about g, where g is x squared plus 1 over f of x. So we want to find out stuff about the derivative of g. So how do we find the derivative of this? We got to use the quotient rule. G prime ought to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Everybody good with that? I think those were all ninths down there. I think I cut that off accidentally. Those are all ninths. So then we want to find g prime of 2. So that ought to be f of 2 times 2 times 2, so 4f of 2 minus 5f prime of 2 over f of 2 squared. Ignore how awful that bracket turned out to be. And then we'll just figure out what f of 2 and f prime of 2 is. So f of 2 is 3. So that should be 12 minus, and then 5 times f prime of 2. F prime of 2 ought to be the slope of f at 2, which that slope looks like it's up 4 over 1. So a slope of 4. So 5 times 4 gives us 20. We end up with negative 8 over 9. Does that make sense?
Yeah, thank you.
No problem. Other questions? Sure. So different types of discontinuities. First type of discontinuity is infinite discontinuity. So infinite discontinuity is just when you've got an asymptote. Next type of discontinuity would be a jump discontinuity. So where you're coming in from the left, and then the limit from the left is not the same as the limit from the right. That's a jump discontinuity. It's also possible for a jump discontinuity to have that point filled in elsewhere, or that point could be filled in at one of these points. So I could have done that, or I could have done something like this. Either one of those is a jump discontinuity. And then a removable discontinuity is where we just have a hole in the graph. We may or may not have that point filled in elsewhere on the graph, but that's a removable discontinuity. Whether it's got that point or it doesn't, it's still a removable discontinuity. And then let's see, the effects. I'm not sure what you mean by the effects that they have, but I mean, this one, the limit is you approach it from the left, and the right have to be negative or positive infinity. So that's how you know it's an infinite discontinuity. If the limit from the left is not equal to the limit from the right, that's a jump discontinuity. And if the limit from the right and the left are the same, but the value of the function either doesn't exist or is something else at that point, then that's a jump discontinuity. Does that make sense? Does that answer your question? No problem. Other questions that you guys might have? Page 23 from the graph FRQ. Sure. Give me a second to pull that up. All right, this is the one you're looking at?
Yeah.
Cool. All right, so it's kind of hard to see over there, but this is the graph of f prime. Tells us we have horizontal tangents at -3, 2, and 5, and a vertical tangent at 3. So first off, we want to find all values of x from -7 to 7 where f has a minimum. So a minimum can occur where our derivative goes from negative to positive, because that's when the function goes from decreasing to increasing. So one place would be -1. That's the only place that it goes between negative to positive. And then we would also want to note that at -7, well, actually it says find all values on the open interval. So if that was a closed interval, we'd want to worry about the endpoints as well. And we'd see that the f prime is positive here, so the function should be increasing, which would tell us at -7, we would also have a local minimum, but since -7 is not included on our interval, we don't have to worry about that. Same with if 7, so for this part, at 7, it's increasing again. But if at 7 it was decreasing, we'd have to worry about that endpoint if it was a closed interval. But since it's an open interval, we don't have to worry about the endpoints. So the only place where f has a relative min is at x equals -1. Does that make sense for part A?
Yeah.
Okay. Same thing for part B. So for part B, we want a max, so f prime goes from positive to negative. So the function goes from increasing to decreasing. That only happens here at -5. And we'll note that at +5, it touches the x-axis and bounces back off. It doesn't actually cross through the x-axis there. And so there's no change in the sign of the derivative. So the function is increasing, 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 still increasing after 5 also. Good or no?
Yeah, good.
All right, for part C, we want the second derivative to be negative. Well, if the second derivative is negative, or the derivative of f prime is negative, that tells us that f prime must be decreasing. So anywhere where f prime is decreasing is when f double prime is negative. So that should be from -7, it's decreasing all the way down to this local minimum of f prime, right, where we have a horizontal tangent line of -3. And then it's increasing all the way up until 2. then it's decreasing from 2 to 5, then it's increasing again from 5 to 7. Does that make sense?
Yeah.
Okay. Cool. And then for part D, it wants to know at what value of x for -7 to 7 inclusive does f attain its absolute maximum. And so we might have a max here at, or we have a relative max here at -5. And then we also have a local max here at +7, right? Because this value is, our function's derivative is positive, so the function is increasing until we get to 7. So part D is either x equals -5 or it's x equals 7. And just by looking here at the graphs, we should be able to see that this value at -5, which is a max, it decreases a little bit after there, but then it increases, and this space up here is a lot more for how much the area underneath that curve is accumulating between -1 and 7. There's a whole lot more of that than there was below from -5 to -1. So we would say that it attains its absolute maximum at 7, based on there being more area under the curve from -1 to 5 and 5 to 7 than there is from -5 to -1. Does that make sense or not?
Yeah, that makes sense. Thank you.
Other questions that anybody might have on anything, I guess, on the multiple choice or any other pre-responses? Oh, on a separate note, and this is for those of you here also in person. I did grade quiz 6, and so everything up through quiz 6, I know I kept telling you guys, oh, we're going to do retakes. We're going to do retakes if you need to. Well, everything up through quiz 6, you don't need to retake. You just can fix corrections on it. I don't have the time for retakes right now. So if you need to make any corrections on quizzes 1 through 6, you can just make them and resubmit them. Cool. All right. All right, let's see. Number 4 on the last MC. You talking about the ones that I posted over the weekend?
Yeah, thank you.
The x² + 1 over x³ + 3x - 5 to the third one?
Yeah.
All right, so the integral of x² + 1 over x³ + 3x - 5 dx. So the first thing we'd note here is that this is not the easiest looking integral to deal with, but if we look at the denominator and let u equal the thing inside of that denominator that's a big pain, x³ + 3x - 5, what would du be? Should be 3x² + 3 dx. And we would note that we don't have 3x² + 3 dx, but we do have x² + 1 dx, which is just a third of what we had over here for a du. So I could put in a 3 and a 1/3 here. And then we'd end up with 1/3 the integral of du over u. Sorry, du over u cubed. Almost forgot that cube there. And so if we're going to integrate u to the -3, that means that we need to go up to u to the -2 and then divide by -2. So that'll give us negative 1/6 of 1 over u squared plus our constant, which will be negative 1/6 times 1 over x cubed plus 3x minus 5 squared plus our constant. Choice D. Good or no?
Yeah, I just forgot that you can use the reverse power rule. I was trying to use like the 1 over u and ended up with like natural log of something.
That's on that paper that I posted in Google Classroom that says, like, I don't know, I don't remember what it's called, but it's like, what is it called? It's called AB. I don't know. It's like, it's the one with all the hints and tips and tricks and stuff, not the long one that I wrote out, but the other one. There's a list of 10 things not to do on the AP test, and one of them is universal, we call it universal logarithmic differentiation. This does not equal 1/3 natural log absolute value u cubed. Right? It is not that. So remember, this has to just be du over u or dx over x for you to get the natural log. You can't just take anything that's in a denominator and then integrate it and say, oh, it's natural log of that thing. That's not how it works. Don't do that.
Yeah,
Oops.
thank you.
Yep. It's one of the most common mistakes that students make. So. Be uncommon. Don't make that mistake. Other questions? If not, I'll come up with some extra true response for us to work on. So that should be the integral from 0 to 2 of 6 minus 4 ln 3 minus x dx. And what did you come up with for that on your calculator?
I got 6.817.
That sounds good to other people? All right, cool. Nobody else responded. Hopefully somebody else did this. All right.
I don't know. Wait, I don't know if that's right because I did it a different way. Like I did just like the area of the rectangle, like with width 2 and length 6. So like 6 times 2 minus the integral from 0 to 2 of that function.
Should be the same.
Okay.
Yep. Yeah, I mean, either way, if you think about it, if you separate it out, it's an integral of 6 from 0 to 2. Or that's 6x from 0 to 2, which is 6 times 2. So that's 12, and then minus the integral of this. So same thing. So for part B, the volume, if you take this region and revolve it around the line y equals 8. So that ought to be pi times an integral from 0 to 2 of the outer radius squared. Well, the outer radius, if we're going around y equals 8, is the distance from 8 to the function. So that's 8 minus 4 ln 3 minus x is that outer radius squared. And then minus your inner radius, which is 8 minus 6, or 2, squared dx. And what did that come out to be? guys get a value for that or no? $168.18. Sure, sounds good to me. Make sure you don't round to less than 3 decimals though. I don't know why I put a 6. You said 8. And then part C, region R is the base of a solid. The cross sections perpendicular to the x-axis are squares. So this should be an integral from 0 to 2 of the distance here squared, because that's the area of the square. So that ought to be 6 minus 4ln 3 minus x squared dx. Everybody good with that? What did that come out to be? $26.267. That sound good to everybody? The few of you that seem like you did this.
Yeah, I got the same thing.
Excellent. All right. I think that'll be probably good for today.